Hello, welcome to this session on AlloyDB for PostgreSQL. My name is Sridhar Ranganathan, the product manager for AlloyDB Google Cloud. And in this session, I'm going to talk about two critical features of AlloyDB. One is to accelerate analytics. The other one is the semantic search, all both in real time. The agenda is pretty straightforward. We'll go over what are the challenges with data silos and how AlloyDB for Postgres handles that. And I will walk through the two critical features, which is Analytical Accelerator and AlloyDB AI. And I'll end with a customer story who uses all these capabilities. Right? Let's start with what is AlloyDB for Postgres and what challenges it is solving and how it maximizes value for your data. So every organization typically needs some form of operational data to keep track of their online transactions and also helps with fast lookups and all. Data is typically stored in a row format. And it is meant for typically to capture your transactions. Okay, and if you want to do business insight, if you want to do reporting, right, you typically have an ETL process that picks up data from here and then dumps into an analytical database, and then the data is typically in a different structure, basically in a columnar format that helps with complex queries, addressing those insights aspect of it. And we also, with the new advent of this Gen AI, if you want to generate more user-friendly experience, then you need to have a vector database. So in order to create the vector, you create a separate vector database and you do ETL, you dump your data there, create, generate embeddings, and then you serve your Gen AI applications. So as you can see, when you have data moving across different databases, it creates this data silo problem with the data redundancy. There's a consistency problem. There's an integration problem. There could be data delays for various technical aspect of it, right? And also impacts the business in terms of higher business cost, inaccurate insights if you don't have the latest data, and poor decision making, and also missed opportunities, right? So pretty much this is the picture many enterprises are running into. And AlloyDB for Postgres is there to address their problems. It's a single database that is typically a transactional row store format, plus it will double up as a columnar store and also as a vector database. So it can solve all the your analytics workload, your transactional workload, and also Gen AI. So before going in detail to some of those features, I just want to highlight what is AlloyDB for Postgres. It's a fully managed database from Google Cloud, 100% Postgres compatible, and it has best of Google in terms of engineering, in terms of infrastructure that kind of helps you with a massive scale deployments. It has several autopilot capabilities. We surgically enhanced kernel for scale, and more features we got added, right? And also it allows you to run anywhere using AlloyDB Omni. In the next few minutes, we'll be talking about Analytical Accelerator and AlloyDB AI, those two critical features of AlloyDB. So if you want to learn more about AlloyDB, there's a link I provided towards the end of the session. Let's start looking into that real-time analytics, business insights, how it is done in AlloyDB. So AlloyDB has a built-in feature called columnar engine. Okay, it's off by default, but you can turn it on. Once you turn it on, it creates a memory structure in a columnar format. And then it's a cache structure. It's nothing stored on the disk, right? And then you can run your regular queries against the row store. And then the columnar basically knows how to pick up those tables and columns and then stores in the columnar format so that you will basically run a query, and then behind the scene, it automatically chooses row or a column and give you the best results. Okay, and basically what it enables is single data store for both your transaction and analytical workload. It's more like a hybrid transaction workload there, HTAP mode. And it is fully 100% compatible. So you don't have to change your queries to take advantage of the columnar. So what it does is 100 times basically faster analytical queries. Okay, no schema or application changes needed. You can just point your application to AlloyDB, and basically AlloyDB itself 100% compatible, so it just runs. And behind the scene, it chooses row store or column store depending on the query. Okay, you can drop analytical indexes, so you can further improve the OLTP performance because there's no overhead of maintaining those indexes. And you can scale independently, right, on each replica. So AlloyDB has the concept of replica nodes for horizontal scale. So you can either turn on the columnar on the primary or any of the reader replica for scale purposes. Okay. What are the features of columnar engine? It supports large variety of data types, including JSON, JSONB. And it helps accelerating table scans, especially with full table scans, right? So it has several features like Bloom filtering, joins, and then group by aggregation, sort, top key, like all those improvements are done as a part of the engine, and it takes advantage of the SIMD instructions also, like to vectorized processing there. So with all these combinations, what it gives you the 100 times more better performance. And we also changed the optimizer or updated the optimizer to choose row store, column store, or both, depending on the query and what gives you the best performance. And we also built an advisor to tell you like whether your application benefits from columnar. So since all application, all type of workload are not suitable, but you can choose to turn it on anytime. So basically, like you can choose to run DB advisor recommend, which tells you like whether your workload takes advantage or benefits from enabling columnar. If so, like you can go and turn on this flag. Once you turn it on, it runs in an autopilot mode. So it auto-populates data every 1 hour. And then if you run your workload, it knows the queries, it knows what table and columns to be populated, and it does it automatically for you. Okay. And also like refresh of cache, like when the data is there on in the columnar, but if you keep updating your regular row store data, that get refreshed automatically. The cache get refreshed. And sometimes like you have the tables and columns sitting in the column store, but you're not running any queries against for it for a while. And if some other query is coming in that could take advantage of it, so the eviction and repopulation all taken care of automatically. So these are all the automated mode. And we also provide manual control to do a few things like, the frequency of population. If you want to do on-demand, verification and population, it can do. Specify the memory size. By default, we reserve 30% of memory, but you can go, you can update higher or lower depending on your requirement. And also some of the flags that persist table and column names. Used for like even after restart, if you want to persist those data, you can do that. So those are the flexible controls you have. So once you enable it, once you run your applications, and how do you know whether columnar engine is being used, right? So we added more parameters to explain, like, we can see columnar engine as a parameter there. So it gives you a little bit more debugging diagnostic details. If you look into the explain plan details. So in this example, you can see the rows removed by column filter or rows aggregated. All those things are like, columnar engine is coming into play to accelerate your analytics. And you can monitor like which tables are being stored or which columns being stored in that using those some of the queries that we already have. Okay, just to give an example, like there is a simple revenue analysis query that basically does a sum for the revenue from a table, and then with some predicates there, discount code between some numbers, right? So this is a simple query. And when you run it without columnar, it probably takes like 3 seconds or 2 to complete. But when you enable with columnar, as you can see in that in the picture where it uses the Bloom filter to remove things. Okay, it also does the aggregates. And with all these capabilities, it doesn't need to scan the whole table, right? So with the Bloom filter and all. So what you can see is like the same result, you get back in 22 milliseconds instead of 3 seconds. It's more than 100 times improvement. This is just an example, and then customers, a lot of customers have even more than 100 times improvement they have seen with their with enabling columnar. So just to recap on what I said, like it is AlloyDB, the columnar engine is part of the engine, so there is no need, no separate costing involved there. It's all part of the AlloyDB. Can enable it anytime. It provides real-time analytics and business insights, and it accelerates analytics queries. You don't have to do any change. Like you just turn it on, the engine will take care of it. Okay, and you can monitor the usage. Last but not least, like we are continuously improving the columnar engine, like adding more data type support, optimizing those data types to get even more take advantage of the columnar. So we do all those. Okay, so that is kind of a quick intro on the columnar side, and we have detailed documentation. We recommend you to just take a look, and then you can understand the more deeper capabilities of analytics. Secondly, we move to that AI. So basically, AlloyDB is going to help you with your journey. Businesses are excited about this LLMs like Gemini, that how potentially it can help with both end user experience, like your customer's experience, and also like your employees. The challenges are like, when you want to provide a good experience to your customer, you have to provide a domain-specific knowledge. So LLMs, if you just go and ask a question about, like, what is my return policy on for this company that doesn't have enough data, it basically gives you with something. We call it as hallucination, right? So it gives you some data, but it's not the real one. But you need a domain-specific knowledge, accurate information, contextual user experience, and then security is important. We do it, and also we want to make this whole GenAI ecosystem experience, creation, management, all those things easy, right? Those are the challenges. So how to bridge between these two? Like, there is a LLMs or foundation models, and we have this need for the GenAI. So this is where the operation database come into the picture to bridge the gap. Okay, operation database has the latest data and is trusted, and you have been using operation database all the time. And the vector embeddings, the vector is what, as many things that stitches all these things together, vector embeddings. So you probably may know about it, but just want to level set, just want to give some background on what is embedding and what is vector. So let's say you have a lot of images, videos, text, and all those unstructured data. So there are a bunch of deep learning models, with the custom encoders. You pass it information, and it comes out with vector information. The vector is nothing but a sequence of numbers representing a semantic meaning for any entity. Okay, so and then you create index on top of it. So pretty much it's all clustered together, and that's where you can do the semantic search, the similarity search. Just to give another example here. So vector embeddings, we talked about how you convert using that embedding models into numbers, and then you create index, vector indexing top of it, and then you can run the search on top of it. The bottom you can see a table is basically a sample of the toy store, where you have a bunch of toys there with a description, and we create vector on top of description. So you can see some random numbers there. Okay, but behind the scene machine basically understands it, and then it kind of structures in a way that when somebody asks for, let's say, give me list of recommend soft toys, then it knows that teddy bear and stuffed toys are part of soft toys. It won't show you puzzle or building blocks or an action figure kind of thing, right? So that's a semantic thing that machine knows, and that's the power of that vector embedding there. So how does AlloyDB fit into the picture? So AlloyDB is nothing but it's integrated set of capabilities to help your build your generative AI applications. So pretty much you enable the vector in AlloyDB, and then what it does is you can convert existing operation database into a vector database, right? So basically it will allow you to add columns that is supported by vector, and then you can do embeddings. So we also support embedding. I will walk you through in a bit on how you can do the embeddings. And then you can run a standard queries, as you can see in an example. There's an embedding query and also a traditional regular queries. You can combine those things together to get the result, right? So it's pretty amazing. And the general flow is something you have those embedding done, just like a toy example we give, or in this thing, we talk about several policies at the database is holding, and then you're going to create an embedding for those policies. So once you have that, let's say a customer coming in saying that, hey, what's your return policy? What happens is that natural language question is converted into a vector embedding by an embedding model, right? And then it kind of searches for AlloyDB for that result. And then we package that result and then send to LLM as a prompt. And then the LLM will be able to result back to that the customer, okay, yours is 60-day return policy, right? So this is more the RAG model, where you have the grounding of data, rather than giving some random data there. So now I'll walk you through a couple of ways on how you create embedding and also store and index. Okay, so this is Vertex AI integration. So there is the Google ML integration extension that is available. You just enable it, and then you can use that embedding function with that text embedding gecko. So basically, you send any string then or any data, it will create a vector embedding for you that you can use it to store it. And you can also do that ML predict row on this, right? And then when you talk about embeddings, we mentioned about Vertex AI, but you can potentially go and enable it from the local models or third-party models, wherever you want to connect to. You can do that. That's a new feature that's currently in preview. So you can register your model, and then you can run your embeddings there. Okay. And then once you do the embedding, you can also store it. This is done using the vector, PG vector extensions. So we That's the open source PG vector extension for Postgres, and we picked it up and we enhanced it to go much faster. Okay, so you just create a table with that column vector, and then you can store it. You can create index on top of it, and you can just use it. So pretty much, as you can see, your existing table structure, you create another column, convert it into an embedding, and then you can boom, the current one will become your embedding database or the vector database. And to speed up that whole process, the scan is a new index type that we added on top of the IVF flat indexes that we have. This is pretty much the same technology that we use behind that Google search. So we kind of optimized and used it for AlloyDB. So what it does is compared to HNSW, which is the most popular index for vector today, but it kind of improves on it. And then when you run the scan index, it provides up to 4 times faster vector queries, 8 times index creation, in much faster index creation, 10 times higher write throughput, and then it uses lesser memory, 3 to 4 times. So pretty much scan is practically like a more recommended index for your vector operations. And last but not least, the natural language support. So there's also a new capability which is currently in preview, where you can ask any questions to AlloyDB for the data thing. If it is an airline database, you can ask for when is my flight, when it is arriving, and all those kind of things on an Integral, and then it will provide you with the query results. So how it does is it provides maximum flexibility, meaning it doesn't restrict you to use only specific words, but you can have a general question there, and then it is secured. You are not allowed to see somebody else's data in the same way the other way also. It's fully security enforced and improved accuracy. Just like how humans, we for disambiguation, we ask clarification questions, so back and forth. So it does the same thing before it gives you the result, right? It's completely developer friendly. It has APIs and building blocks to help with your GenAI journey. So net, we are continuing to improve and add more capabilities to AlloyDB AI into natural language, model access, and also vector search capabilities. And we also have integration with the LangChain if you're interested in. Right? It's available in AlloyDB and AlloyDB Omni, which is downloadable version of AlloyDB. Okay. So I'm going to talk about a customer story, Neuro, who basically uses all these technologies I mentioned to you, the transactional, analytics, and also the GenAI stuff. So Neuro is basically a technology company that develops autonomous technology for using what they call as Neuro driver. So it's pretty much this car goes around and captures data, and then it's a massive amount of data it is collecting, and it is storing it on GCS. And Neuro has a bunch of custom models that they run. They pick up data, they analyze it, and then using heuristics and then ML-based one. And then they push a lot of data into AlloyDB to store as metadata. It's more like all those simulation and then the privacy, security kind of thing. All these things are stored. And then they also use the analytical workload, the columnar engine, to do some analytical workload. And at the end, they kind of capture all those things and also send data back into the drivers so that they will get much improved experience, and they want to see. It's more like a cycle. They just keep doing it to capture more data from the cars. The technical architecture side of it, AlloyDB is the centerpiece for their entire applications, where all the GCS, the metadata ingestion and all that comes into AlloyDB. They also have this embedding models, they generate from their structure, the video and all, into vector embeddings in AlloyDB. And they also run analytical workload like OLAP, and then several things on the analytical side of it. Plus, they also open up for transactional workload for customers to do their OLTP log and the screen hub verification. They do most work on AlloyDB, but they also stream data to BigQuery for some of their the dashboards and a few other things, but they are switching users between them, and then they want to standardize on AlloyDB. So net, their experience is they like the hybrid transaction, analytical, and vector store as a single database to solving all their problems. And then they really like columnar engine capabilities and vector indexing, and they provide a lot of feedback to us. Basically, we work very closely with them, and then we enhanced our service for them. And overall, Google Cloud ecosystem, right, with the AlloyDB, with the data stream, with the BigQuery, and pretty much they are running their business more effectively on Google Cloud, right? So just now to summarize the whole thing, AlloyDB is a single database for all your data silo challenges. It provides you real-time insights. It will make it easy for you to generate GenAI applications. It gives you much better price performance than doing your self-managed Postgres there. And it's 100% Postgres compatible. Okay, and that is built for the future and ready today. As mentioned before, here are some links that you can take a look to learn more about AlloyDB, the overview, documentation, and also there is a resources which provides the links for various videos and blogs and the latest happenings with AlloyDB. With that, thank you so much for your time. Really appreciate, and please feel free to reach out to us if you have any questions or concerns. And also take a look into that resources or the documentation, that link I provided earlier. Thank you again for your time. Appreciate it.